Everybody, Mr. Bowman here, another 2.7 calculus video. This is on all the merit questions of the 2021 exam. Just a heads up, these are all past NZQA paper questions. I've kind of compiled them all in one place for convenience, so I thought I'd run through them for you as well. If you want more questions, check out the link in the description. That'll take you to more. So let's get straight into question number 35. And this one here, I kept on doing a few math errors the first time I did it, so I might have even got this one wrong as well. But we've got our function there. It's a cubic. And we've been asked to find the tangent when x is equal to 2. So let's start by jotting down my function. So we've got fx is going to be equal to 1/2 of x cubed plus 1/2 of x. So I guess the first step is we'll kind of split it off. We'll do some work down here, but the crux of the question is the tangent, which is y equals mx plus c. So thinking of my strategy, I've actually been given x already, haven't I? That's going to be 2 up here. I can find out m with a gradient function. That involves me differentiating this to get a gradient function. I can find out y by substituting x back into the original function. And then finally, that means I'm going to have to use algebra to get c. So let's start with y. So y basically is we're going to substitute this in here. So when f2, we'll be able to find y. So it's going to be 1/2 times 2 cubed plus 1/2 times 2. So it looks a bit messy, but it's pretty easy. So that 2 cubed is 8, and then times 1/2 is 4. So it's going to be 4. 1/2 of 2 is just 1, right? Plus 1, so that's 5. So that means y is going to be equal to 5. We already have x. Remember, x is equal to 2. We've now just got to figure out m, then we can use algebra to get c. So m is the gradient, so we're going to need a gradient function. So f dash x. So differentiating this here, remember, we times the power by the coefficient. So it's 1/2 times 3. That's going to be 3 over 2. So 3 over 2, x squared. The power's dropped by 1. That's there, so it's going to become plus 1/2. So we've got that there. We can now substitute in 2 to find out the gradient to that particular point. Or I've written x, but that there should be a 2, shouldn't it? Because we're trying to find out the gradient at 2. So it's going to be 3 over 2 times 4 plus 1/2. Doing the math, so 3 times 4 first, that's 12. 12 divided by 2 is 6. Plus 1/2 is going to be 6.5. So I've now got my gradient as well. So m is equal to 6.5. I can now sub all of these in together to get my c value. So that tells us that 5 is going to be equal to m times x. So that's going to be 6.5 times 2 plus c. Simplifying that middle bit there. 6.5 times 2 is 13 plus c. And then I'm going to take away 13 to both sides. So that means c is going to be equal to minus 8. So now that I've got that, minus 8, I've actually done a math error there, haven't I? We're looking good. We can now put that all together to get my final tangent equation. So y is going to be equal to 6.5x minus 8. Moving on to question number 36, and then this flows into question number 37 as well. So we've got the number of daily viewers of some kind of video gaming streaming service can be modeled by this equation. The equation is only valid for between 0 and 48 months. V relates to the number of daily viewers, T relates to the number of months, and we've been asked to find the rate of change of viewers when the daily viewers is 3,520. So I guess the first thing to note is we're trying to find the rate of change. So we're trying to find V dash. That's ultimately going to our answer. And we know that we're interested only when V is equal to 3,520. So we've got a few bits of information. Let's start off with finding something to do with V dash. So V dash is going to be equal to negative 11t squared plus 528t. I'm now going to differentiate this to get V dash. That's going to be negative 22t plus 528. Now, to find V dash, we've got to know something to do with time. But the issue here is we've got something to do with V, not T. So what we're going to need to do is we're going to need to substitute 3,520 to my expression to find out what T would have been when there was that many viewers. So it's going to be a bit annoying. So remember that V is going to be equal to negative 11t squared plus 528t I know that v is 3,520, so it's going to be negative 11t squared plus 528t. This is a quadratic here, so I'm going to make it equal to 0. I'm going to move this over to the side here. Then I'll use my graphics calculator to get the answer. So 0 is going to be equal to negative 11t squared plus 528t minus 3,520. So now that I've got that, I'm going to pull that into my graphics calculator. Remember that A is equal to negative 11, B is equal to 528, and C is equal to negative 3,520. And when I put that in my calculator, I got two answers for T, which is interesting. So there's two different possibilities that we need to consider. And what were they? They were 8 and positive 40. And noting both 8 and 40 are within my time range, so they both could possibly be valid answers here. So I've now got time, so I now need to figure out the rate of change for both of these 2 points. So let's figure out, for T1, we'll figure out V dash, the rate of change. So that's going to be negative 22 times 8 plus 528. And remember, that comes from my V dash formula. So I've taken out the T and put in 8, which is the first answer. And when I calculated that, I got positive 352. That means it's changing positively by 352 viewers per day. So it's on the way up there. And then now we can figure this out for the second time. So V dash is going to be equal to negative 22 times by 40 plus 528. And that came to negative 352. So they're kind of a bit symmetrical in terms of the parabola. And that tells you the number of viewers are going down by 352 at that particular point in time. So doing question number 37 down here, because it carries on and there's actually not that much working. So we're looking for the maximum number of time. So I want to note you can figure this out by kind of finding the midpoint of these, which would have been 24, but that was using algebraic methods and not calculus methods. So be really sure, make sure you're using calculus methods. So let's try to find the maximum in terms of a gradient function. So we know that our gradient function was equal to negative 22t plus 528, and we know at this maximum v dash is equal to 0. So we're going to substitute that in. So 0 is going to be equal to negative 22t plus 528. That there is going to be 22t is equal to 528, and then t is equal to 24. And that confirms the midpoint thing over here, but we've used calculus to get there as opposed to just kind of finding the middle in our average. So now that I've got that, I can substitute 24 back into my original function to find out the number of viewers at that point. So the viewers at that point will be equal to negative 11 times 24 squared plus 528 times 24. And putting that into your calculator, I got 6,336. So the maximum number of viewers this streamer got on a given month was that number there. We're now on to question number 38. And again, these graph ones are always the worst done questions in terms of student performance, but hopefully we'll be able to sort this out. So I guess the first thing to note is this graph has a kind of 4 x-intercept, so it's beyond a cubic, it's what they call a quadric. So this here is going to be something to do with x to the power 4, and it's actually a positive quadric. You may or may not have learned that in your graphs topic. If you differentiate a quadric, you know, for example, if we differentiate x to the power 4, that's going to become 4x cubed, which is really just a positive cubic. So that's kind of the first feature that's going to be really important for this graph. It's got to look like a positive cubic. That kind of means it's going to start from up here, it's going to turn, it's going to go back down, then it's going to turn again, and then it's going to go again. So it's going to kind of have that shape, but obviously we've got to get the points in the right spot before we can draw that. So the next thing we can talk about is, because it's a gradient function, we can always get the turning points. And luckily we've actually got quite a bit of information on the turning points here. So the turning points occur when the gradient is going to be equal to 0, right? So we can see a turning point up here. So what's that? Negative 1, 2, 3, 4, 5, 6. So that means we're going to have we've got a minimum when x is equal to negative 6. We've then got a maximum when x is equal to 0. And then finally, I'm assuming it's symmetrical at this stage, we've got another minimum when x is equal to -6. So we know all of these here are going to be the turning points. So that means the x-intercept of the gradient function must be these ones here. So that's going to be the x-intercept of all the functions that we have. And I guess the next thing to note is by inspecting the graph itself, we can kind of see what the gradient should be at all points. So we know the gradient has to be 0 at each of these 3 turning points. But we also know this here, we can physically see the graph is going downwards. So that's got a negative gradient. From here to here, the graph is going up. So it's going to have a positive gradient. Here to here, the graph is going down. So again, it's a negative gradient. And then finally, up here, the graph is increasing. So it's a positive gradient. So that also gives us a bit of information to check the parabola itself, or the cubic itself. Just switch to the pink pen so we can kind of see this graph take place. So the first thing to note is the turning points, right? So we already know where these x-intercepts will be. So there's going to be one over here, one over here, and then one over here. So they relate to the maximums and minimums, our turning points of these graphs. And again, we've got a positive cubic. So we know it's going to rise to this first turning point here. This first intercept, and that makes sense, right? Because this here, that's the x-axis, so this area here relates to negative gradients, which matches what we've got here. We're expecting a negative gradient. After that point, it's kind of going to rise and then fall back down. So if we go from, connect here to here, so all of this area is on the positive area of our axis, and that relates to the positive gradient that we've seen here. The next thing is we've seen a bit of a negative gradient here. So it's basically going to be this, but it's going to be mirrored kind of below down. So it's going to go there to there. Again, we can see that's all below the x-axis, so it's a negative gradient. And then finally, we can see the last bit of the cubic increasing there, and that's in the positive territory, and it matches the positive increasing gradient that we see at that particular point. Now to question number 39. And we've got a function here, and this one's a bit weird because we've got a constant, a c, an unknown c there, so we're going to have to figure that out. At what point, so the point at which we know, so x equals 2, we've got the gradient there, so that tells us x equals to 2 when f dash x is equal to -5. So we could substitute both of these into a gradient function, is maybe what I'm thinking. And all we've been doing is asked to find the value of c. So I think that's what we're going to do. We've got information on the gradient function, so we're going to differentiate this to get to the gradient function. We're then going to substitute in this, and then that should let us get c as the answer. So let's get into that. Let's start by jotting down the original function. So fx is going to be equal to 5 plus 3x plus cx squared minus 2x cubed. As I said, I'm differentiating this to get f dash x. So 5 is going to differentiate to 0, so we can ignore that. 3x is going to differentiate to 3. Cx squared is going to differentiate to 2cx. And then finally, negative 2x cubed is going to differentiate to negative 6x squared. So I've got all of that there. I can now substitute all of these goodies in, and the goodies being x equals 2 and a gradient of 5. And hopefully that'll let me figure out c. So let's put all of that in now. So that means -5 is going to be equal to 3 plus 2c times 2 minus 6 times 2 squared. And the nice thing about this is we can see that c is the only letter left there in the middle. So we're going to use algebra to find out c. So -5 is equal to 3 plus 4c. This here, 2 squared is 4. Times -6 is -24. So we've got -24. Simplifying my right-hand side first. So -5 unchanged is equal to, what's that, -21 plus 4c. I can move my -21 over to the other side. That becomes positive. Positive 21, so that's positive 16 is equal to 4c. And then c is equal to 4. And that there wraps up C. So that was actually a nice, easy question. It looked pretty complicated, but once you got into it, there wasn't too much to it, eh? So we're now on to question number 40. And we've got a cliff diver. That's them up there. They're kind of leaping off, coming back down. Their acceleration is constant. So we've got an acceleration formula. Let's jot that down. So acceleration in terms of time is -9.8. And straight away, because we're seeing acceleration, we know it's going to be a kinematics question, right? The jumper has the initial velocity of 2.8. So what that tells us when t is equal to 0, velocity is equal to 2.8. So we're going to need that information later on. And we've been asked specifically to use calculus methods to find the velocity 1 second after they jumped. So we're going to need a velocity expression here. So the way we can do that, to go from acceleration to velocity, we've got to integrate. So the velocity in terms of time is going to be equal to negative 9.8 t plus c. So I now need to find out c, and that's where the 0 and 2.8 information is going to come in. So we know the velocity is going to be equal to 2.8. So 2.8 will be equal to negative 9.8 times 0 plus c, which means c is equal to 2.8. I'll put a dot there, forgot that. So that means the velocity, the expression for the velocity is going to be negative 9.8 t plus 2.8. So now that I've got that, I've got my velocity expression, I can now substitute, because it says 1 second, so we're interested in the velocity when t is equal to 1. So the velocity when t is equal to 1 is equal to negative 9.8 times 1 plus 2.8. And putting that into the calculator, because as soon as I see negative signs, I tend to make math errors. So let's do a no-risk approach. It's going to be negative 7.8, and its velocity, so it's meters per second. Now on to question number 41. I've gone back to grey. I've completely forgotten so many questions, I've forgotten what colour pens I've already used. I try not to use the same one twice, but we'll probably use it twice in this video. So we've got a gradient function here. We've been told the original curve passes through the point 1, 2.5. We've been asked to find the coordinates of the original function when x is equal to 2. So to find these coordinates, we need to find the original function. We need to find fx. So let's start by jotting down my gradient function. So f dash x is equal to 6x squared plus 5x minus 1. I'm now looking to integrate to get my original function. So fx will be equal to, so that's going to be 6 divided by 2 plus 1, x, 2 plus 1, plus 5 over 1 plus 1, x, 1 plus 1, and then we've got minus x and then plus c. So hopefully you can see those clearly there, but minus x plus c. I can now simplify all that fraction stuff. So basically 6 divided by 3 is going to be 2, so that's going to become 2x cubed plus, this 5 over 2 can't be divided, so I'll leave it as a fraction, 5 over 2 minus x plus c. You can put that as 2.5 if you want, but I always prefer the fractions. I find them more useful later on. So now that I've done that, I'm going to pull out the information from the coordinate. So this coordinate 1, 2.5, that tells me that x is equal to 1 and y is equal to 2.5. And that's really useful because basically there's going to be a y there. So that will give us enough information. If all the x's go, all the y's go, we've got one letter, we can solve for c. So 2.5 is going to be equal to 2 times 1 cubed plus 5 over 2 times 1 squared minus 1 plus c. So 2.5 will be equal to, so 1 cubed is 1 times 2 is 2. This over here, as I said before, is going to be 2.5, so that works out really well. So it's going to be plus 2.5 minus 1 plus c. To make it easier, these 2.5s will cancel, so 0 will be equal to 1 plus c. So c is equal to negative 1. So from here, I can now put that together and state my original function. So fx will be equal to 2x cubed plus 5 over 2x squared minus x minus 1. Now, I haven't answered the question. I've done a heap of work, but I haven't actually answered the question. I've been asked to find the coordinates when x is equal to 2. Remember, coordinates are x, y. I've already got the x right, that's 2. So I need to put x equals 2 into my original function to find out what that y is actually going to be. So f, 2 is what we're trying to find out. So f2, so that's going to be 2 times 2 cubed plus 5 over 2 times 4, which is 2 squared, minus 2 minus 1. So 2 cubed is 8, times 2 is going to be 16. And then this here, so 5 times 4 is 20, divided by 2 is 10, so it's going to be plus 10 minus 3. And all of that comes to, what's that, 26 minus 3, so it's going to be 23. And that's the final piece of the puzzle. I can now state my coordinate being 2, 23. So we're now into question number 42. Geez, this feels like a mammoth video, the 9th merit question in this exam, but question number 42, we got there. Basically, we've got a gradient function. We've been asked to find the original function. So a pretty typical graphing type question. Again, these are always poorly done, so hopefully it's something you'll be able to practice to make sure you're getting the marks. So the first thing to note, the gradient function here is a negative parabola. So if you think of a negative parabola, it could be negative x squared. If you're integrating a negative parabola, that power is going to get bigger, right? That's going to become a negative cubic. So this one here, to be specific, will become negative 1/3 of x cubed. So that means our original function is going to be a negative cubic. So you notice I always do the same approach. I always start thinking what the graph's going to look like. So negative cubic. So what I know about a cubic is a negative cubic in particular, it's going to go down like this and then back up, then down again. So they typically have, so we've got a turning point over there and then we've got another turning point over there. We've got two turning points where the gradient is 0. So we can see on the graph there, so when x is 2, and what's that there, 2, so that's 4, 6, 8, 10. So the second turning point will be at 10. So one turning point there will be at 2, and the other will be at 10. So we've also got some information on the turning points. We don't have much else with this one. Sometimes you have more information, like maybe they sneak in a coordinate down here or something like that, but we don't. So we can start plotting this here. So we've already got information on the turning points, as we said, and just to note, I'll draw a vertical line just so you can see it. So that turning point can sit anywhere along that line, going up and down, anywhere when x is equal to 2, and the same with the second turning point, that can sit anywhere along x equals 10. So what we're going to do is we're going to draw a line, so we know we're going to start going downwards like this. So we're going to draw a downwards line that then curves. Let's kind of draw a point here, and it kind of starts to curve into that turning point that I've just drawn. So let's go downward line, and then it starts to curve into that point. And then from that, we know the next turning point, the maximum, is going to be somewhere on this next line. So let's maybe just say it's going to be here. So this line here is now going to increase until this point where it's going to start curving back down. And then finally, it's going to start going down like that. So we can see there we've got a negative cubic, and the turning points are in the right spot. So that wraps up the ninth merit question for this 2021 exam. If you're looking for more merit questions like these, check out the link in the description to this video, and you'll see heaps of merit questions, I think all the way back from 2015 to present, and they'll be a really good source for your revision.